Okay, so I think we're not quite done with the nitty-gritty um, byte and stuff parsing yet. Um, okay, because there's still something about the, like, how do you understand the stuff in the loca table? Um, so yeah, where does it talk about the loca table? Okay, so what is in the loca table? Um, so it's just going to be like, it's not even going to be all this stuff. It's really just what's in this offset column. Like there's going to be like this integer followed by that integer followed by that integer. And that's just supposed to mean that like if you want glyph index 0, you look at this integer. And if you want glyph index 1, you look at that integer. It's like just a big array of integers. Like that's really all it is. The question is though, what kind of integer is it? Like, is it a 16-bit integer or a 32-bit integer? And uh, unfortunately, there's not a straight answer for that, and that's probably for reasons. It says the size of the offset depends on the format used. Um, and this is specified in the head table. So, okay, now we have to look at what's in the head table. Even to understand what's in the loca table, which um, we're already using the loca table to figure out what's in the glyph table, which is what we really want. Okay, but this is actually like fairly straightforward. Okay, so this is the integer that we're after here. And it just says it's 0 for short, offsets 1 for long. And I forgot where it says it, but I guess short offset means that it's 16 bits and long offset means it's 32 bits. Trying to find where it says that. Oh, here, yeah. Yeah, there's the loca short version and the loca long version. Like they're both just big arrays of integers. But yeah, the short version is 16 bits and the long version is 32 bits. So I'm not gonna actually implement both versions. I'm just gonna check which version we have in our one font file and just implement that and maybe just have like a assertion or something, just in case we end up trying a font file that we didn't write the code for. Okay, so if we want to figure out whether the loca is the short version or the long version, we need to check the head table. So yeah, let's get the table directory entry for head. Head table directory entry. Table directory dot get head. And I'm just going to okay, so this thing, it might be undefined. So yeah, I'm just going to say like if, so that's going to happen if there's no head table, but I'm just going to ignore that case. Throw new error. Like I'll just throw an error if that happens. No head table in font file. Okay, but now we have the table directory entry, and that tells us the offset, and it also tells us the length, although the offset is really what we care about. So, okay, so where in the head table is the thing that we want? There's like all this stuff in the head table, but the only thing that we want is this indexToLocFormat. So let's just count up everything from the start to see how many, yeah, like to see how many bytes we need to add to the beginning of the head table. Beginning of the head table is this head table dirEntry.offset. So we'll need to add something, and for that, let's add up all of this. So, okay, let's figure out what all this like fixed and stuff is. I think it said that like on this page. Oh yeah, the data types. Okay, so fixed is 16.16-bit signed fixed point number. I mean, that just means it's 4 bytes. Okay, so actually, let me just copy this into something where we can easily, yeah, I'm just gonna paste it here, get rid of the stuff that is just like part of the description. Okay, I'm pretty sure that this is everything. So, okay. So we got 0. So that's like offset 0, offset 4, offset 8. And then that's 32 is 4 more bytes. So that's 12. And then this is 16. And then uint16 is 2 bytes. So there's 18 and then 20. Long datetime, I'm pretty sure long datetime is going to be 64-bit. Yes, it is 64-bit. So this is going to be 28. And then 8 more is 36. F word, that is 2 bytes. So that's 38. And then 40 and 42 and 44. And these are also 2 bytes. 48. Whoops, 46 and then 48. Okay, and then we got 50. And for completeness, we can say 52. But yeah, this is really the number that we wanted to add here. Okay, so this tells us where that one number that we want is in the head table. So view.get, and what was it? What was its type? I mean, it was just a 0 or 1, but I'm gonna try to do it quote unquote properly. Okay, it says it's an int16. So we can get an int16 at oh, whoops, I'm supposed to say if it's not yeah, if it doesn't exist, then throw the error. Okay, so yeah. So this should be indexToLocFormat. So what is this number that we've spent all this effort trying to figure it out? It is 1. So that means that it's a long table, and a long table means, where does it say loca? Okay, so that means that it's 32-bit. Like each offset is a 32-bit number. So the loca table is a big array of 32-bit integers. All right. So I'm just gonna say, I'm gonna do another like throw an error sort of thing. So like, I'm just gonna force the indexToLocFormat to be 1. And if it's not, then I'm just gonna say like throw an error, we can't handle this. So just to narrow the scope of what we're doing. So only long format loca supported. Okay, cool. So now we can we need to get the what's it called, loca table. And I'm kind of thinking that like we're gonna need several tables, and I'm gonna have to write this every time unless I create a utility. So I'm gonna create a utility to get a table. Or I guess to get like the table directory entry. Yeah, I might as well just do it as like a inner function here so I can use the various locals. So you can put functions inside functions. Get table dir entry. And this is just going to do this sort of stuff. And instead of hard coding the word head, I'm going to use the tag. And for this, I'm going to use a format string so I can format the tag into here. Let's fix all of this. Okay, and then we should just be able to say const head table dir entry equals get table dir entry with a tag of head. Okay, cool. And we should also be able to do the loca table. Okay, and this didn't this didn't provide any kind of error, which is good. Let me actually put something else here just to see us get that error. Okay, yeah, we got an error. No loca something table in font file. Okay, that's good. And then this is, yeah, this is not an optional or anything. This is a required thing because we are throwing an error if it's not there. Okay, great. So now we can just get any table directory entry that we want. So yeah. Yeah, basically I wrote this as an inner function because I wanted to access the table directory. Otherwise I would have had to like pass that as another parameter. I mean, I could have done that, but it just would have been a lot more work. So now I can just pass the tag and get the table directory entry. Okay, so what we're doing, we have basically a big 32-bit array of offsets into the glyph table. So I don't know how many of them there are going to be. I mean, I guess we can find out from the entry's length. If we just divide the length by 4, that should be the number of loca entries, which is also the number of glyphs, right? Number of glyphs. Yeah, so that's 4,504 glyphs. I wonder if we can corroborate that information with, like, I don't know, is there some kind of info or like properties? Does it say anything about like how many glyphs are in this file? Okay, I guess not. Oh wait, actually, wait. Can we open with fonts and then will it tell us info? Oh, okay, yeah, the glyph count is 4,503. And we got 4,504. Okay, I think I know why there is a one glyph discrepancy. And I will get to that in a little bit. But yeah, rest assured that it is a good thing that we've found 4,504 as our number of glyphs. Cool. Okay, so now not only do we know the number of glyphs, we also can find where each glyph is. And maybe I'll just do like the first 10 for now. I don't know. Or actually, what the heck? I'll get the information for all the glyphs. Okay, so let's do for glyph index equals 0, glyph index is less than num glyphs, and then glyph index plus plus. We have location equals loca table, or actually we need to get it from the view, so we want to get a 32-bit integer because that's all that's in the loca table, and we want to get it at LocaTableDirEntry.offset, which is where the loca table is, plus 4 times the glyph index. So yeah, that's how we will offset into the loca table, and then we can console.log I guess glyph index and then its location. Okay, nice. We have we have our 4,503, or I guess 4,504 glyphs, and we have an offset for each one. So great. Let me turn this into an actual array. I'll call that loca. If we just push okay, I think it's a little confusing to have like LOC and LOCA as different things. So I'm going to rename this to locations. So then you should be able to just print the locations, and that should be the same thing. Okay, cool. We have an array of all of the locations. Yeah, I noticed that these are all the same. I also noticed that the first time I did this project, and I still don't quite have an explanation of why glyph number 1, glyph number 2, 3, and 4 are all like the same glyph. There's probably some explanation, but I just don't know. But yeah, it looks like 5, 6, 7, 8, 9, 10, they're all different glyphs. Now we have the locations in the glyph file of each glyph index. So yeah, this function is getting kind of long, so I'm gonna, and it's all in the main function. So what I'm gonna do is like a little bit of organization. So I'm gonna make a new file for all of this parsing stuff, parse font file, or maybe I'll just like say, oh yeah, parse font.ts. I'll make a function in here, export function parse font, and this will get like the array buffer. The one that we can get from our font, from our response from our request, or we can get array buffers from other places too. And it's just going to return a big array of just like stuff about the font file. And the great thing about TypeScript is you don't have to specify the return type if it's going to be just like an unknown sort of big object. You can just return the big object. And this is going to have like num glyphs and then whatever else we're going to need. So yeah, most of this is going to go into that function. So let's just take all of this and put it in here. Oh yeah, and this should also go in there. And then we can call that from our main function. So parse font array buffer. Whoops, that's not array buffer. Okay, so the thing that this can return, I guess for now, we'll just look at locations because that's the latest thing that we parsed. And this, if you're not familiar, this basically just means return an object with a key of locations and a value of also locations. So this is actually kind of short for locations : locations, but since the name of the key and the name of the variable that holds as values are the same, TypeScript and JavaScript let you just do that. Okay. So that means that we can get locations in the main function. And there it is. We have our locations. So it's the same thing as we had before. Wait, hold on. Oh, whoops. I said console log, but what I meant to do was a const locations equals parse font. Okay, yeah, that's what I meant to do. Yeah, what this does is like these braces. If this returns an object, which it does, this extracts the locations key. So this is kind of like doing the opposite of doing this. And if you're confused as to why I did this is so that we can put also other stuff like num glyphs, whatever else we need to parse out of the font file. And then we can now also get num glyphs out of here. And now those are separate variables. Okay, cool. So now we have somewhat more separated parsing logic. Okay, so now we've parsed the loca table and we have a whole bunch of offsets now to index into the glyph table. So in the next video, we're going to start looking into what's in the glyph table.